one of our main agenda items, and part of our charter is to understand what's going on, who's doing what in the standards development landscape. And we're really honored and pleased to have Professor Marius Preda with us today to talk about the activities going on in MPEG and their sort of sphere of ISO. So ISO standards, again, front and center. And how we're seeing that process produce all sorts of great innovations. So we'll get to hear about that. And we'll kick off with Marius, since I know he has an engagement.
Okay, hello everybody. Glad to be here. And yeah, I will try to entertain you for about 20 minutes. I hope to stay into 20 minutes. In general, I take a lot of time to speak, but now I have to be short. So this presentation, I entitled it Compression Needs and Opportunities in Metaverse. And the main point of today is that I think that without graphics compression in general, but particular graphics compression, we cannot really speak about Metaverse, at least not about appealing Metaverses that we would like to design. And just as observations, this happened in the past in the video domain, when the video applications really took off back 30, 40 years ago, was because the compression was there. So this is why we had video streaming almost everywhere. And so the key point is that compression is not a nice to have, but is mandatory if we want to create appealing metaverses. And of course, you all know that MPEG is doing compression in multimedia space, and particularly video and audio. And my presentation of today is also to remind some work that we did in the past in MPEG for graphics compression this time, but more important, what we are doing now in graphics compression. So I will try to start. Okay. Yeah. This is also based on a presentation I recently did in Webs 3D in San Sebastian. So if you were there, you already know the slides, but I think they are fun to check. So my point here is what we would like to have in terms of compression is something that people already imagined in books or even movies. You all know this movie. But what we retain from here is that we want to have realistic digital content. Here I'm talking about graphics content, but it should be realistic. We would like to have natural visualization and a possibility to interact with this content in a rich manner. Still, what we have today, when we look to the immersive applications, they are relatively simple in terms of content. We may browse images, videos, or sometimes even some 3D graphics. The visualization is still not natural. We have to wear these helmets. They are improving more and more, but we are not yet there to use them daily basis. And we have some interaction. Another example that I took from movies, and it serves me to also talk about the loop, real to virtual to real. So things are happening in real. We want to map some of that in metaverses, and then interacting in metaverses, we want to have mapping back in real. I think this is very important. We don't have to see the metaverse like a world by itself living there. Of course, there will exist this kind of metaverses completely unrelated to the reality, but I think much more improved experience would be if we have this mapping done. Why I am mentioning that is it means that we have a lot of data from physical world to the virtual world and back. Again, natural visualization and interaction a must, and my motto of today: high quality digital content, high definition, high quality digital content. And here I'm referring not video content, but graphics content. Okay, what we had recently noticed, and a lot of people get excited about this simple example, we had still some realistic content, but was relatively simple in the sense that a simple scanner can do that, and not a very complex scanner, but something based on photogrammetry, videogrammetry. And we have this simple interaction of two people speaking one with the other. But still, that was amazing to have it done. Okay, so we may say, what is going on? There is a real gap between what we imagine to have in metaverses, and this is not recent; it comes from years, and what we are really having today in terms of technologies. One of the question is: are we lost? Are we just taking too much time? Are we not focused on what we have to do, or are people are not yet ready? So all these things should be somehow identified and answered. Yeah, just a slide about history of developing visual representations. My point here is we always try to go towards realism. As soon as we discovered the way to represent realistic content, and here I'm referring to paintings, we tried to make it realistic. And that happened in the traditional way of representing visual assets, but also it happened with computer graphics. Even if we started very simple with some geometric primitives, always the trend was to create more and more realistic visual content. And of course, the breakthrough was the invention of the photograph. Okay, what is also happening these days is the shift between in the way how we consume the content. If for years we consumed the content as simple spectator, the content was on a wall somewhere. Even today is on the wall. We still watch television that is on a wall. But there is a shift happening, and this is in the new way of having access to this visual content, mainly based on mobile phones, but more and more, and we hope even more in the future, by using VR or AR glasses. I will not go in the details, but you all know this. Okay, so one of the question is if we are ready in terms as humans, and I think we are, if the content is there. But then the question is, what is the content that is, what is the technology that is now available? So we have a lot of interest, and what is happening now is not only an interest in research community, but a huge number of companies covering the entire chain from production, different ways to capture content, different ways to transmit, and different ways to render content. They're all interested in what we call today a metaverse. Is a nice name, but for sure is not something new. What is new is this huge interest of a lot of actors, and that is a requirement for making having it done, because we are targeting mass markets. Okay. Then my point here is that in all these, there are a lot of components, technological components that are needed for sure. And one of them are the glasses themselves. With current glasses, I don't think we can go mass market, but there are new ways of improving these glasses. I will not talk about glasses. I'm just saying that is an important element. Without good glasses, everything else that we are doing for nothing. But my point here is that a keystone in all these applications still is the high quality content. So being able to produce, being able to consume, and being able to move this high quality content from one place to the other. And of course, when we are saying content, high quality, it means that is a lot of data that should be represented. How we create this content nowadays? we have these two ends from visual capture and visual synthesis. You know the ways of visual capturing, taking images, videos, more and more resolution, more and more color depth, rigs for multi-angles. These are technologies that exist. And on the other side, a lot of improvement also in terms of visual synthesis, algorithms for creating real-time content based on graphic primitives. And we have more and more capacities to create this in real time with approaching realism. Okay. So if we put them together, there is a clear distinction in terms of content creation between the two. And there are some characteristics of each one. On one side, we have the easiness to produce high quality content as long as we have the material. And on the other side, we have by design this interactivity, because we can interact with any object in the scene. They are very well defined, but also the immersiveness in the sense that we can create any view and as many views as we like. So one of the questions would be, what if we are trying to put these advantages together and have a representation format that allows to have both? Okay, so here we are talking about high quality, realistic and interactive content that looks like in the images here. And as I already mentioned, is a must for, in my opinion, is a must for Metaverse, for the new wave of Metaverse. Otherwise, we will not create appealing application for end users. But since it's heavy, for sure, we have to have a way to compress it, because it's not an application that you have it on your PC because you download it the night before. Is something that will go from one peer to the other in real time, as real time as possible. Okay, so since we are talking compression, I can introduce the WG7 MPEG 3D graphics and haptics coding. This is a new working group in terms of structure, but it is the continuation of a subgroup of MPEG for that exists for years. So if you see this WG7 and you believe that is new, is actually a continuation. Okay, so what we are doing, application agnostic. It should cover a variety of raw data representation model. We know that there's no yet a unique representation model, and different in 3D graphics, and it's much better to have use a universal one. But still, there are big advantages of having a universal single representation format, and as a community, we have to move in that direction, trying to set up a common base. Is not something that we do as a representation format in MPEG. We are taking representation formats that exist, that are done by other communities. One is SE24 that together with Web3D created VRML and X3D, but it can also be GLTF created by Kronos or any other representation format. On top of these formats, what MPEG is doing is putting compression. And where compression is needed, actually is in the middle of the chain, in the sense that the capturing, authoring size doesn't matter. We can create whatever models we want. On the publishing, rendering size doesn't matter either. It should be even as flat as possible to go directly in the graphic card and be rendered. But in the middle, we have to have a representation that is compact enough to be transported. So in general, compression doesn't change the representation and should not change the representation. But even if we look at this slide, the requirements that we have on the right part and on the left part are completely different in terms of data representation. That is an additional difficulty we have to handle. Okay, why we do that is, of course, that 3D graphics is like any other media. This is not something new. And since we have more and more 3D graphics content available, for sure, it should be compressed. So I will move on. I have here a chronology of what we did in MPEG. And we started soon after VRML was released in 97. In 98, MPEG added compression for two kind of data, which were the meshes and the face animation. So on top of VRML. And later on, adding other compression techniques. I will not go in all the details. I will make the slides available to you, and you see different years with different technologies that were proposed. And I'm referring here to compression technologies. At a certain moment in 2009, we also had a model that is called MPEG 4 Part 25 that showed how these compression tools can be applied to third-party representations, and at that time was on X3D and Collada. Maybe we should revisit that for GLTF and other formats today. Some other things happening. You remember in the year 2010, we all oriented the development to the web. We said the web is the platform, so MPEG did the same and adapt the compression techniques to the web browsers. And there are now technologies that allows to have compressed graphics in the web browser. This is all available. Okay, here a summary of what kind of representations were addressed at that time in terms of shapes, texture, animation. The list is relatively big. In parallel with that, and later on, actually was triggered by the context of Second Life. If you remember, in 2000, 2007, 2008, we start also to work on interfaces for getting signals from the real world and controlling actuators in the real world. So this is done under MPEG-V, which is called Media Context and Control. And we are interested here in the data formats, of course, in a compressed manner, that are sensing, that are used by sensors and by actuators. But an additional point at that time was also the interoperability between virtual world, in the sense that we would like to have assets that are created in a virtual world and transferred to other virtual worlds. So it's very similar with what we encounter today as requirements in metaverses. At that time, we were also interested in natural interfaces, and that was under MPEG-U. Okay, I will move on. Yeah, a format for AR when we will have more time. That is the architecture of MPEG-V, but we don't have time to speak about. Here is some illustrations about the interoperability between the virtual world, in the sense that these objects were created in an application and used in other virtual worlds. And the commonality was that the decoder, the encoded representation of that objects were common, and therefore it is possible to decode, and like you would have a video, but instead of video you had a 3D content. And one particular kind of object at that time was, of course, the avatar, which is not a representation, visual representation in terms of geometry, appearance, and animation, but together with the avatar, there is also some other specificities that should be represented, like personality, skills, and communication skills, cognitive skills, and so on. Is more kind of metadata on top of graphics representation to create an avatar. And for sure, in the new trend of metaverse interoperability, avatar is one of the key elements. And in my opinion, it will be the first element where the interoperability may apply, because people would not like to create avatars for each virtual world, but they would like to reuse them. Okay, MPEG-RF, I will not go in detail, but because I don't have too much time, what I would like to talk about is what we are doing now, and also try to answer to the question why MPEG 3D graphics compression is not well deployed and well used, despite the fact that we did that in the last 20-something years. And in my opinion is that we, in the past, the content we had was relatively simple content, in the sense people could zip it and have enough compression for their needs. But now there is something happening, which is this trend of going to natural content where the volumes are much bigger than what we did before in graphics. Okay, so the question is, what is the most appropriate form to represent this realistic content? Of course, video plus depth can be used, and at the receiver side, people can synthesize new views, especially if you have many videos plus depth. But there is also graphics representations like point cloud and meshes that can be obtained and used. And so what we are doing now, we are working on compressing these new forms, point cloud and meshes. In general, point clouds, so here is an example of point cloud is the graphics object, in the sense that you can turn around, you can see it in VR, in AR. The specificity is that it was captured with an important number of cameras, about 40 cameras, and reconstructed offline, and then use it as an object in a virtual world or in a game. Some other examples that you already know, because they are public, by Microsoft or by Intel, using this combination of video plus 3D graphics in the sense that it is a graphics object, but it represents a natural content, a real content. And one point here is that if you want to represent one of these small persons, you have to, in a non-compressed format, you need between 1 and 3 gigabits per second, depending on the resolution and the motion, how fast is moving. Okay, so for sure compression is required. Other examples, but I will not go in all the details, but I will just focus on some numbers. So let's put it simple. This example here, the lady, she has 8,000 points, which would be more or less, let's say, 1,000 megabits per second. Okay, just to have some numbers. How compression is done, of course, I will not go in all the details, is not completely new, compression of point clouds, but there are few things that we focused in MPEG. Of course, the main idea is always to find predictors in the 3D space that allows to reduce the amount of data to be used. And then in the literature, there are some constructs that allows to have a more predictable space. Octree and KD3 are these constructs that exist. Same, I will not go in detail, but the idea is to replace a 3D representation XYZ with a tree that will have branches that will serve as support for prediction. And in the case of Octree, we are cutting the space into uniform cubes. And in the case of KD trees, the cutting will be done not with respect to the uniformity of the cube, but to maintain the same number of points in each sub tree. And why this is important is because all the branches will have the same, more or less the same length, so it will be a more balanced tree. These are compression stuff that, if you would like to have more details, I would be happy to have discussion with you. But the point is, these things are new, are known, sorry, in the literature, and we try to apply. The problem of KD3 and Octree is that when we deal with animated content, like here is an example, imagine we have this point to code. If the point, because of the motion, will go into another subcube, then the tree will be destroyed in that particular space because it will go up. So prediction is not so nice. We want to correct this and propose new methods. And here is the schedule. We start very early this work. We had a call for proposal in 2017, and a lot of work was done since there. And we end up with two solutions for point cloud compression, one called VPCC and the other called GPCC, with the idea that VPCC is using video codec and is is well designed for dense point clouds, and GPCC can compress any sparse or dense, and the prediction is done with Octree and other 3D mechanisms. So I will just give you some information about how it is done in terms in the VPCC. The main idea is the point cloud is projected on planes, and for each 3D point is transformed into a 2D pixel, for which we will keep the color in a 2D plane, the distance from the plane to the real point, and additionally there is an occupancy map. So the point is a 3D representation is transformed in a set of 2D representations. And since MPEG is good in video coding, that videos will be, of course, encoded as traditional videos. They don't look as a traditional video. The compression performance, of course, is not as good as a traditional video because it looks very noisy in terms of jumping, but there are a lot of tools that were added in the standard to make these videos less jumpy. Okay, let's speak about numbers because that is the most important. The examples you saw before, so we're saying 1 to 3 gigabits per second. Once we are using this VPCC, it is reduced to, for this example here, 7 megabits per second, for this one 4.4. So up to, let's say, up to 10 megabits per second, you may have content that is very good looking, that we can see it in the glasses. That is important to know. Okay, some implementations available, decoder, encoder, they are all available in terms of software. People start to use. There are a lot of publications as well. What is happening when the content is not dense, so cannot be easily projected? And here we have the GPCC that is taking this kind of content, like we have in LiDAR. The numbers are different here. For 100,000 points at 10 frame per second, in uncompressed version we are about 110 megabits per second. And when we compress at a very good quality, we may have a reduction to 16 megabits per second. These are few examples. That is lossless. If you want to go lossy, of course you can go less, and you may easily imagine the applications that are triggered by this codec. Whatever we will have in the autonomous or assisting driving should be compressed to be used. Okay, some new activity on AI. I will not go too much there, but most important is an activity that we are doing in mesh. Point clouds are nice, but we know in the 3D graphics world that meshes are much nicer because the graphics cards are prepared for that. The specificity here is that it's not an animated mesh as we are used to handle before, but is a mesh that will, at each frame, of course, the vertices are moving, but also the connectivity is not consistent. So there are some particularities that should be considered when we do compression. So we start an activity on that. It is ongoing. The results are relatively good now. I can tell you already what the solution is. It consists in having a coarse mesh that will be encoded by any graphics codec, and starting from this core mesh, coarse mesh, by a subdivision surface algorithm, we add details, and these details are encoded as videos. So we are still reusing this video ecosystem to compress that, and the numbers currently are very good. Okay, I took more time that I intended to take, but let me conclude here. You already know that MPEG is doing compression. Many of you already know that MPEG is doing compression of graphics as well. And I think we are doing that in a good way, especially when we are considering realistic content for which zip or simple codecs will not be enough. And for sure, that is something to be considered in whatever interoperability discussions we may have in Metaverse or other VR, AR applications. I also have here the logos of people that are involved. MPEG 3D is quite crowded these days. There are at each meeting about 200 people online from different companies with a lot of activity. Okay, I'm finishing here, Nicola. So of course I move it very. I went very quickly, but I would be happy to have discussions by email or even some chats with any of you if you'd like to have more details.
Okay, great. Thank you so much, Marius.
Thank you.
Do you have time to take a question, or do you must run?
Yeah, let's have a question or two. Yeah.
Okay, thanks. Yeah, and we can follow up with the discussion on the listserv. I think
it's very frustrating to not have questions. So if there is any question, of course, I will take.
Okay, great. Anyone out there on the call want to ask? There was a little bit of discussion in the chat about, and I provided a little bit of background for folks about the different subcommittees inside ISO. So 29, 24, and so on and so forth. Can be hard to keep track of those, but the question was actually about interoperable avatars, and because you have such great videos of characters and stuff. Is there? Oh, go ahead.
They are not avatars in the sense of course they represent people. They can be used as an appearance of the avatar, but more than the geometry and the material, the appearance, there is nothing else. So it should be considered as a starting point to defining an avatar framework indeed. But he's already solving an important part, which is the representation of the heavy content, which is the geometry and animation and the appearance. And on top of that, so with some metadata, it can become an avatar.
Right. I see the difference, and it's really fascinating the sort of direction that you guys have been able to, and the results you've been able to get. But that an avatar would maybe have more of like what we're thinking of, like some kind of standard armature and rig that can be moved across platforms.
Okay. Sharing some animation sequences, and there is a lot of things to be considered when we want to have interoperable avatars.
I believe there was some discussion at Web3D. Not sure if it was a colleague of yours, but showing the MPEG reference humanoid.
That's what is an attempt of creating this interoperability, it stays, let's say, at one side of the spectrum, in the sense that everything is well defined, and people can use that avatar. Of course, you can change the appearance, you will have another appearance, but in terms of connectivity, is exactly the same connectivity, which has a lot of advantages because you can control it in a consistent manner over all the avatars. But that is one solution. I don't think it's the unique solution. Other solutions may appear, and also on the other end, we may have avatars that can be transcoded. So you still have your own representation format, but you can transcode it into another representation format.
Right, I see. Good. Johannes, did you have a question?
Yeah, I have one question. And there was something I was just curious about. Now, with the vision capturing, you're moving more to data or that is really captured from the reality, and some like point data that's close to the original sensor, and that's really impressive what you do there. But I'm wondering, so do you see more captured data or more digital born data in the future? So I see really a mixture of, like, we usually have a lot of cut data or others that is really comes and then has meshes or PWebs or NURBS. And on the other hand, have point data, scanner data. And the tricky part is always how to mix and match both. And do you see a more in your compression domain, more focus on captured data and therefore more regular data, or is this something just recently in your
I also believe both will exist. One of the difficulty of having graphics, good quality graphics content was the cost of producing it. And we had these authoring tools. You hired a lot of people to create nice looking content, not necessarily realistic, but nice looking content. And we add triangles and triangles and triangles, but that was a kind of constructivist manner. And it was costly. What we have now new is that this capacity of creating content in a less cost manner, and that looks good. But both type of content will coexist for years because there are advantages. One thing that I see now is that even if we consider CAD content, imagine that you already have the 3D the object. Imagine that we capture that object and we create, starting from that capturing, a CAD model that will be later on enriched with some metadata and properties and functions and so on. So I think what we have with this new way of capturing content is that the base will be higher than starting from scratch in creating even CAD content.
Yeah, but sometimes you really have to start in the digital space, so you don't have
because
a
you
real
don't have
object.
Indeed. And a lot of things can be generated. I have a lot of hopes in generative 3D content.
Exactly.
Like AI generative. And there will be more and more content that will be learned. So even the way how we will create CAD content will not necessarily be from one triangle adding another triangle. We will have models that will generate things and that we can manipulate to create the final CAD model.
Okay.
Good. Nice question. Thank you.
I had a similar question or input. The picture which you showed, the video with the soccer or football match, where you told you have to transmit all the polygons of all the players, right?
Sure.
Maybe there are also approaches, I think there are, just transmitting the pose estimation, do the pose estimation and transmit the pose data, right? And then already the whole players on the other side, so you just reconstruct it.
Sure. That will also be something that will coexist, in the sense that when we you capture the real persons, and then you have the point clouds or mesh and you transmit it, but there is not too much intelligence inside, in the sense that is the same content that you capture. Of course there is this compression and you send it and you render, but the key would be if you capture and then instantiate a template that will be later on shared with the template that is at the receiver side. And of course this will happen as well. We have already basic avatar models like the one in Ajanim. We have more complex that are proposed in the scientific literature, and I have a lot of hopes that we will go also in that direction, starting from realistic content to initiate some parameters of a template and have a very, very realistic representation at the end, template based. Yeah, indeed.
Makes sense. Yes, thanks.
Excellent. Well, I love this this discussion. This is exactly what we want to have. And but Marius, I know you have to go. I see a hand here from Chris. Do you have time for?
Yeah, let's hear Chris. And anyway, I'm late, so.
Okay.
Sorry.
It's okay.
First of all, thank you for your presentation. So we're the web interoperability group. So I'm kind of wondering what the story is with these technologies in use in web browsers today. Is this compatible with existing web technologies, or are there gaps that you see that would be needed in the web platform to support these kind of compression techniques?
Yeah, that is a good question. In the sense that how much the web technologies will offer as a support for these technologies. Let's put it directly. Currently, there are implementations of MPEG codecs in the web, and the way how it works is that the entire codec is in software. So it's JavaScript decoder, and you can do it. One of the quality of VPCC, let's talk only about VPCC, is that it's using video decoders. And there are three for this displacement, the attributes, and the occupancy map. And then you combine the output of these decoders, and you create the 3D content that you can render in the web. The beauty of this design is that other than the video decoders that can be heavy because it's hardware accelerated and the browser supports that, but other that part, everything else, which is software implemented, only software, because the combination of the output is a very thin layer in terms of processing. So JavaScript can do that with no problems. So I see there is no barrier in having the codecs, especially when they are based on video codecs, implemented in the browser. The question is, can the web technologies provide more than a canvas where you display things? Maybe, but even if it's not the case, what we have today is good enough.
Great.
Good.
Okay.
I will thank you guys, and I will look forward to continue to participate to these meetings for sure.
Okay, great. Yeah, please do. And we'll be back in 2 weeks. Okay.
Great.
Okay.
See you.
Thank you, Marius.
Bye.
Thank you.
Thanks. Yeah, that's fantastic. And I know there's a lot of things we can talk about in there. I've taken some notes. We may have to sort of push these ideas maybe into the next meeting, but they certainly provide some more food for thought, especially when we're thinking about our use cases, right? So, Chris's question about the web browsers is great. And that was about decoding, but of course, what about the encoding, right? How expensive is that in terms of cycles or licenses or whatever? The other one, glasses or no, I thought it was pretty interesting. Maybe it was just in passing, but sort of tying this idea of the metaverse with the glasses. And I don't really think that's a common thing. I think some people might make that association, but then, you saw the next slide is someone holding an Android phone with a mixed reality app, and that's certainly not a headset. So I thought that was interesting. Sort of that question of, is the headset really required to participate in the metaverse? I think a lot of us on the web think no, right? So that's interesting about browsers and the compression. I was glad to see that some of those techniques are lossless, right? If I'm doing LiDAR in an autonomous car, like I want every point, okay? I don't want to compress away some bush or a person or a dog. So a lot of really good stuff in there. And maybe we'll roll that into our continued discussion on use cases. I think it gives a lot to think about, and also from the Metaverse Standards Forum perspective, as an SDO, MPEG clearly has a lot to offer in terms of 3D capabilities there. Excellent. Yeah, and LiDAR would be maybe one little touch point we could use to say, like, okay, what's a use case around this? Hint. So yeah, we have a couple of things in front of us as a group, which we want to I guess, identify and figure out a path forward. So the first one is we're in our chair nomination cycle. So that means basically as we started, I guess the email to the group went out on the 10th of November, and the nominations are, initially due tomorrow, the 17th. For folks that are curious, by coming to today and the 30th, our next meeting in 2 meetings, that would put you into good standing, which would make you eligible as a chair. So that's something to keep in mind, and I'm going to continue to kind of reach out and chat with folks about their ability and willingness to be nominated. So that's our housekeeping thing, and I just would like to encourage folks to remember that you can nominate yourself. You can, but it's great to nominate others, and the process is basically to put the nomination onto our working group listserv. So that email address. Oh, great. I know I'm getting something wrong. So Neil's going to help me about this procedure.
No, it was almost right. It's just the good standing, you're correct, good standing, but that's for voting. You don't actually need to be in good standing to nominate.
Thank you. Okay, so, that's a great clarification.
So if someone is here in the meeting and thinking of nominating but haven't been to the last 3, that's okay. You'll want to be in good standing though, obviously, if you want to cast a vote. So
thank you. That's important. Yeah. Okay, great. Thank you, Neil. So that really does open up the field, and I hope that each of you again will kind of consider how the interests of you and your customers and your company can benefit from your leadership here. So we really encourage you to think about that.
Maybe a bit silly question. What are the duties if you are as a chairman or here?
That's
maybe I missed first meetings.
Yeah, no, that's a great question. I actually have it here. Some about the process, and then the responsibilities. So are you guys seeing this screen?
Yes.
Okay, perfect. So the MSF has a great staff and set of support technologies and things in place. So there's actually a lot of the mundane things are sort of taken care of, and really the working group chairs are intended to sort of keep the agenda and the roadmap kind of on track, right? So organizing this week, that week, who's talking, what's the topic, here's the materials. In our charter, we do have a timeline of milestones, right? So we have things that we're planning to deliver and publish starting in the spring. So keeping those projects moving. And am I forgetting any other really important duties of the chair? I should also say, and again, correct me if I'm wrong, but the guidance from the Metaverse Standards Forum is like 3 or 4 chairs, right? So 3 to 4. So it's definitely a team effort. I think it's really fantastic if we can find, chairs from around the world with some different perspectives and time zones. That can only help, but this is kind of what I guess we would expect to make a functioning, a productive working group. So does that answer the questions, Saniar?
Thank you very much. And the process is just over the web formular or just per mail?
Yeah, let's see where I put this. Is in here somewhere probably.
I mean, I can also check the slides, but if it's
there. It must. Oh, here we go. Sorry.
No problem.
So the nomination period, Friday the 17th. Here's the email for nominations.
I also put it in the chat, Nicholas. It's there.
Okay, super. Thanks, Anita.
Perfect.
Great. Great. Okay, so please do feel free to reach out to myself or Anita or Johannes if you have any questions about those duties and what that might look like for you. We'd be happy to go over that and make sure that you know we're charting a good path for everyone. So please do feel free to do that. We're running out of time, but what I wanted to kind of do was also to remind folks about the use cases. And we made some progress at the last meeting, but I'm not sure that we've made much since then. So I think we have a Thanksgiving holiday coming up here in the US. That's an extra day off or something. Maybe I'll go walk in the park and work on some of these use cases. For sure, it's not because there aren't any, right? It's basically because of each of our time limits and dealing with the template form. That's the barrier right now. But I really would encourage folks to, again, by putting your customers and your use case into this format, right? It means that your requirement will live into the future of the MSF, right? And it's documented and it's something that we can all point to and see, does this actually work? Or could this work? I want to do and again, not because that they don't exist, but more like I think it's just us sitting down and writing it. But there are a bunch that we could think about too, which are over at web3d.org. These are real use cases, you know, that are going over the web and multiple platforms, interactive 3D. So I think there's an activity too, and maybe I'll assign it to my students to basically take these and encode them in the use case template. And there's a whole bunch there.
Did you add the use case from the white paper that we published a year or two ago?
I am not aware if we do. We have these three. So what was that one? Sorry, that's Bill. Yeah, hi.
Yeah, that's Bill. Morning. Yeah, in the white paper, we addressed the question of what does it mean to be interoperable in a metaverse context, and what we came up with was a working definition that involved an ability to move seamlessly from one platform to another. Mm-hmm. Without having to exit from a 3D environment, with the ability to take your identity and your data with you. So with the understanding that those platforms would be different platforms altogether, not homogeneous per se.
Mm-hmm. So that's great. Some of those are in My Ride, My Bling, but I don't think it's really as comprehensive as you're describing. So maybe we need to revisit that one and cross-check it with that white paper.
Yeah,
there could be some requirements that we don't want to miss. Yeah,
and maybe Anita can put that in the link to that paper in the chat if she has it handy.
I already did, Bill.
So good.
Oh,
so good. All right, awesome. Well, we're at the top of the hour. I know we have some other things to go and meet on now. So thank you, everybody, for your time today. It was really great. I learned a lot, and I hope we'll get serious about how we can make this working group work for you and keep contributing. So thanks so much.
Nominations are due tomorrow, and you're welcome to self-nominate yourself. So please feel free to do so. All you need is a paragraph on what your expertise are and why you would like to engage with this group and share the group.
Awesome. Awesome. We've got a lot of talent here, so I'm looking forward to seeing what comes out. All right, well, I'm going to stop the recording and want to just say thanks to everyone again. We'll see you in 2 weeks. Have a good Thanksgiving.
Thanks, Nicholas.
Thank you. Thank you,
Bye.
everyone.
everyone.
Bye-bye.
Thanks,
Bye-bye.
everybody.
Bye.